Welcome back to my channel, everyone. What we have here is a bag of jeweler's scrap. The jeweler swept off his workbench, and he got all these little bits of metal off of his workbench. And so today what we're going to try to do, you can see there's carat gold in here. There's going to be some silver, probably some platinum, some gold wire, silver wire, some carat stuff, plus there's going to probably be some junk metal in here. So he's already done the hard work and sorted through all this and picked out all the little pieces of metal that could be valuable. I see something right here that's not. That's a burr that he uses to do jewelry repairs with, so we'll exclude that. But right now what we're going to do is get a weight on this before we start. I've written the weight on the side of my Corningware dish here. 912.5 is what the empty dish weighs. So I'm going to throw it up here on our scale. And we've got 1,006. Let me see if I can type this in over here. We've got 1106.3 minus the weight of the dish, which is 912.5. So the total weight of all this material is 193.8 grams of scrap that I got from the jeweler. So we got 193.8 grams of material from the jeweler. 193.8 grams. Someone suggested using a plastic cup, putting a magnet down in here. So that's what we're going to do. Sounds like a pretty good idea. We're going to go through here and pull anything that's magnetic out of our scrap. Now what we're pulling is mainly just the catches that have a steel spring in them. So I think we've got just about all we're going to get that's magnetic out of this material. Now I'm going to pull all the gold stuff, put it back in here in the main batch. This will be catches made out of silver and gold. But then some of them, like that one right there, I don't think is gold. So I got to pick through all this stuff and get it separated so we can take out the non-precious metals materials and give that back to the jeweler. Here we go, the sorting is complete. Here's all my little bits of metal, pieces off of the jeweler's workbench. This is all the non-gold material that I sorted out of it. I'll return that to him. And then I got a couple of diamonds down here and some other gemstones to return to him. Now what we'll do is we're going to take this out and we're going to process these bits of metal in nitric acid. Here's our jeweler's material. As usual, the first thing to do is incinerate it, burn it, and burn off any combustible material. I've got a 2-liter beaker here, and what we'll do is add a little distilled water, about 100 milliliters. Now we'll just dump the incinerated scrap right on into the water. Now what I'll do is add some nitric acid, and I'm going to boil this scrap in nitric acid, kind of like inquartation, to remove all the silver that we can out of this scrap. And the nitric acid will dissolve the silver, but it will not dissolve the pieces of gold. Cover it up, and what we'll do is stick it up on the heat back here and let this react to remove all the silver and nitric acid soluble metals out of our scrap. This is 20 minutes later, and the reaction has slowed way down. So I'm going to add some more dilute nitric. I begin by filling up this beaker with a little bit of distilled water, about 150 milliliters. Next, we're going to add the same amount of nitric acid to form a dilute solution of nitric acid. And the reason we dilute this is to provide a medium that allows the metals that are dissolving to dissolve into. That's why we add the distilled water. And now I just slowly add it to our reaction, and we'll let this continue to boil in this dilute nitric acid. This has been on boiling for about an hour and a half in hot dilute nitric acid. You can see our clippings down here look nice and clean now. And I think what we can do is go ahead. I'm going to pour off this liquid now into a clean beaker. It's going to contain silver. So we're going to pour the liquid off now into this clean beaker. A little bit of, a few pieces of gold might go with it, but we'll filter this out once it cools off. I just want to get the nice cleaned up gold that's left in here isolated. Alright, here's our gold clippings, filings, and pieces. Now what I'll do is I'm going to add a little bit of distilled water to these pieces of gold in here. They look excellent. We're going to add this back onto the heat. And I think what I'll do is pour a little bit more nitric acid in here and let it boil in some hot dilute nitric acid for just a little while longer. This boil's been going for about another hour at least. We've still got some color in there, which means we're still pulling copper. And if we're still pulling copper, that means we're probably still pulling silver. So we're going to pour this off now. Look at how pretty them gold bits of metal look now after being cleaned up in boiling nitric. I'm adding some more distilled water, and we're going to set this up on the heat. We're going to do another nitric acid boil. We're going to keep doing this until the solution becomes colorless, just like we do with Inquarted gold. I think we're going to call it for the nitric boils now. Fairly certain we've got all the silver pulled. You got to remember, I'm making this up as I go, as usual. Alright, here's our gold. It's looking pretty good down there. I'm pretty sure we've got all the silver pulled out of there now. I've got a specially folded filter paper in my funnel here, so the paper rides up the sides of the funnel. This will ensure that we capture 100% of the particulate that we are about to filter. Here's the solids in the beaker. It's not much, but that'll probably be gold, the mud, and then of course there's some pieces of carat gold there that we want to capture in this filter. Won't be much, but we want to try to get the best yield that we can for the jeweler. While I wait for all this liquid to pull through, what we'll do is we're going to get the pieces of carat material down in our beaker into this melt dish. Here's our carat material. We're going to bring this over here to the melt table. We're going to melt this up now into a little button or bead. Here's our puck of karat gold. It includes all the pieces plus the residue from that filter paper. We started out with 193.8. Let's see what this thing's going to weigh in at. That's 67.1, so we reduced it by about 130 grams here. Yeah, we took all the silver out of there. So now what we should have is just karat gold in this mass of metal. Now let's figure out what the carat of this gold is. And we're going to do that by testing with some acid. I have some gold test needles here, and they have the different carats of gold on the tips of each one of them, a known quantity of gold. I'm going to use the 10 and the 14. We're going to scratch 10 right here on our touchstone. Then we're going to scratch a sample of our little puck in the middle. And then to the other side of that, we're going to put 14K. And what we're going to do now is just go ahead and put some acid on this. And let's see if we can tell what we've got here. First the 10K, our unknown, and then the 14K. This has been on here now for about a minute. As you can see, the 10K from the needle has almost disappeared. Our sample is still clear and bright here. And the 14K known standard from the needle. Those two look very similar, but this is just a little lighter. So now what I'll do is I'll rub another sample off of here onto the stone. And then what I'll do is I've got some 18K test acid. Let's just test it for 18K. It's very doubtful it's going to be 18, but you never know. And you can see there, it's pretty much disappears under the 18K test acid. So it's a little higher than 14 based on this result, and lower than 18. So based on this test, I think what we'll do is we're going to call this unknown sample here that we melted up, we're going to call this 14K gold, and use that to calculate the amount of silver that we need to inquart this gold. So we multiply this by the constant, which is 1.265. So we've got 67.1 times 1.265. Looks like we need 84.8 grams of sterling. Here I've measured out some copper wire. So rather than use sterling silver for this inquartation, we're going to use this copper wire. I'm going to add the gold to the melt dish, add the copper in, and then we're going to go out to the melt table and alloy these two together to inquart this gold with copper. This is our silver solution from the nitric acid boils of the carrot scrap from the jeweler's bench. We're going to just save this and we'll get the silver out of here. Here's our carrot gold that we inquarted with copper. So now what I'm going to do is this nitric right here didn't have much silver in it. It was our last nitric acid boil on the pieces of carrot scrap. So I'm going to add this to the inquarted gold. I'm going to use this to start pulling the copper out of here now. This will take much more nitric acid to pull the copper out of here. Silver dissolves more easily in nitric acid. It takes less nitric acid to dissolve silver, more nitric acid to dissolve the same amount of copper. It has something to do with copper having a higher charge at the atomic level than silver, so that's why it's going to take more nitric acid to dissolve the copper than it would if we'd used silver to do the inquartation. This is our estimated yield, 67.1 grams. Multiply that by 0.583. We're looking at recovering 39.1 grams of pure gold, or 1.2 troy ounces. This was nitric boil number 1. It's complete now. So what we're going to do is pour it off into a jar over here. This jar's got a little bit of residue down in the bottom of it, and I'll just rinse that into my silver jar. And now what we're going to do is pour this off into this beaker. I'm going to give this a quick rinse with some water. Now I'm going to add more water. Set it back up on the heat. I'll add some more nitric acid. We'll continue removing the silver and the copper out of here with these nitric acid boils. Third nitric boil's been on for about an hour. This is our fourth nitric acid boil. Our fourth nitric boil is complete. The gold is looking really good. This will be nitric boil number 5. This is going to be our final nitric acid boil. Looks like we've got just about all of the copper pulled out of there. I'm going to pour it off into this jar. Now we're just going to add some water to this and let it set in some water and cool off down here. I've got our gold that's been parted with nitric here. It's ready for refining. I've got this nitric boils that we use to pull the copper out of the inquarted gold. And a little bit of the gold went over with those boils. So now what we're going to do is filter this solution in the back. I've got one of my specially prepared filters in here so we can capture 100% of the powder that's in the bottom of this beaker. Here we go. We're going to filter this liquid now. Here you can see the little bit of gold that was poured off with the nitric boils. It's not much, but it's will help the yield. And refining every little bit helps. Our flask is almost full. The solution will contain silver and some excess nitric. And the best way to process this is to add some more silver. Consume all the excess nitric that's going to be in here and then recover the silver. Now if you look in here, here's our gold that we filtered out. What I'll do is I've got some water down here. I'm going to add this water. It's going to have a little bit of gold in it to this filter. Pull it through. I thought I seen some purple in that solution, and if you look, right here's a layer of colloidal gold, very, very nanoparticle, tiny bits of gold that have made it through the filter. That's okay, it's not going to be that much. Let me move this flask out of the way. This is our filter. It's going to have some gold in it. So what we'll do is we're just going to pull it right down and add it to the gold in this beaker. Now we'll add some hydrochloric acid. I'm going to add about 200 milliliters of hydrochloric acid. Now we're going to add a squirt or so of sulfuric acid. And what this will do is this will precipitate out any lead that may be present. It's about a half a milliliter or so. Now we're going to shoot some nitric acid in here, and this will form aqua regia, and that will begin to dissolve the gold. 1, 2, 3, 4. That's 5 3 milliliter doses for a total of 15 milliliters of nitric acid. Let's put this up on the heat. And we're going to add a little bit of heat to this. Start dissolving our gold. Let's look at this and see if we've got everything to dissolve. There's a few pieces left there. Not sure what those are. Might not even be gold. And that's just some junk that's burnt onto the bottom of the beaker. So I think we got everything to go in solution. Let's pull this down and let it cool off. Alright, let's cool this off with some ice. We're going to filter our solution now. Don't look too bad. It's got just a hint of cloudiness. Here's the filter. So now that that filter is loaded up, it'd be a good time to put in a new flask. We're going to pass it through this same filter a second time. Now that it's loaded up, we'll be able to filter out the real fine stuff that's suspended in this liquid. Yeah, it's always a good idea to do this. Take the extra time while we have the gold in this state and filter out the little bit of excess cloudiness, probably silver chloride. Oh yes, oh yes. That second pass through the same filter always seems to clean the gold up for us. Very nice. That solution is crystal clear and bright. Let's get this thing out of the way. Now I've got a beaker. I'm going to transfer our solution to this clean beaker. Here we go. Let's go for the precipitation. Using Stump Out by Bonide, which is sodium metabisulfite. Here we go, 1 spoon. Look at that, turns red, man. That is beautiful. That is just awesome looking. It's like a tequila sunrise. One more. I just realized I forgot to test with Stannis. Let's do that right quick while we got the chance. Dip a piece of filter paper down in here. And we'll get some of this Stannis chloride testing solution on it. You can see that we've got tons of gold in solution. So now we'll go ahead and just continue getting the rest of this gold to come out of solution. That should do it. Let's give this a stir. Now let's do another Stannis test, just to make sure we've got all the gold to drop out. And you can see negative Stannis test. All the gold has precipitated out of that solution. I've allowed this gold to settle completely. Took about an hour or so. Now what we'll do is pour off the waste. That gold looks pretty good for a single refining. Not bad down in there. Now let's give this a rinse with some water. Get the excess SMB rinsed off of here. A little bit of gold's going to go over with the rinse. This always seems to help. I'm going to do a hydrochloric acid boil. It's been boiling in hydrochloric acid now for about 10 minutes. Let's get this and pour this off into our waste container. And look at the difference in color in that after that hydrochloric acid boil. That looks fantastic. We're going to go ahead and put this in a melt dish and melt this up and get a yield so I can get that jeweler his metal back. And this gold looks really good. We might pull one off with a single refining, but every time I say that, it doesn't come out just right. So let's see what we got here. I'm gonna melt this up into a bar now. Here's our pure gold bar that we just poured. It's got a little contamination on the surface there, but it does not look too bad for a single refining. Not bad at all. Second refining would have got it nice and clean. 3 9s. This is probably 995 to 998, something like that. And we were expecting 39.1 grams down here. The actual weight is 42.4 grams. So we had a little bit more than we expected. And that's not a problem. Got a good yield for the jeweler. All right, we got to inquart with some copper this time. See how that goes. Went well. So this will conclude the video. Thank you for watching.